So in this in the previous video we observed that the estimate here manually worked out for the Cox Ross Rubinstein tree is equivalent to the result produced by this function, which is VBA code for Cox Ross Rubinstein, and as mentioned previously the code I use here was taken from Volupta. So Volupta website. Okay, and the steps in estimating the value of the European option were initially to set out, provide the typical parameters for option estimation, so the spot price, the underlying, the exercise, the maturity, risk-free rate, Black-Scholes volatility, number of steps that we want to use in our tree, the option type in terms of call or put, and exercise type in terms of is it a European option or American option. Okay, so a little bit of explanation here. From there we set out the time step. So if there are 4 steps and the time period is 1 year, the time step is 0.25. Up and down, which can be from Cox Ross Rubinstein. It's known that U can be estimated by taking E volatility multiplied by the square root of the time step, so E to the power of sigma times square root of the time step, and then the same again, except we could have a negative power, or we could just write it as 1 over U, and then P is the risk neutral probability. We go through the different stages then of constructing the tree in VBA code. So this segment of code here is designed to set out the tree, and if we go back into our manual estimation here on a 4-step tree, 4 steps involve 5 dates. In the 4-step tree we can go up or down, continue to go up, up, so this line going over is going up or going down, and that set of numbers can be generated internally in VBA using this segment of code where we have a double loop, and we specify, if you like, a grid reference for each of the asset prices in the tree using Sij, where I might be taught to denote the row. So row 1, row 2, row 3, row 4, row 5, and J denotes the column. So column 1, column 2, column 3, column 4, column 5. And then from there, once we've generated the terminal stock prices in the tree, we can estimate, if we go back into our code, we then estimate the terminal option prices. So we generate the intrinsic value, so for each node in the tree, terminal node, so the terminal nodes are these. For each of these we generate an intrinsic value of the option, and the way we generate that is we take the stock price at the terminal node and subtract away the exercise, and then we take the maximum of that value or 0, so it's always going to be positive. And likewise, okay, if we double click again, we see that this stock price minus its exercise, and when the value falls below 100 or equal to 100, we have a floor value of 100. So the maximum ensures that we never get a value here in terms of the value, intrinsic value of the option at expiry never falls below 0. So that segment of code generates using the case, is it a call or a put? If we say C, if you designate here, for instance, we've designated that the option type is C, it's a call, and the expiry is E, it's European. So using this CRR tree VBA code, using that function CRR tree, right, we have made explicit that it's a European option and that's a call, so we're using C. And down here then for estimating the value of the option, we've selected again that it is a European option, so we're going with KC. And we're also in this instance developing a double loop. So once we have generated these terminal intrinsic values for the options, we bring down here. So each of these cells are set equal to the cells above. And then from there we start at this point and we say, okay, we want to, using this function which is obtained from Cox Ross Rubinstein. Okay, so if we just take a look at the paper and come down to page 6, we can see that to go back through the tree, we take P, our risk neutral probability, and we apply it as a kind of a discount factor on the value of the option if the stock price goes up, and 1 minus P is a weight we attribute to the value of the option if the stock price goes down, and then we discount using R, and that's the value of the option one step back in the tree. So to view how that's implemented in VBA, it's okay, this is the discount E negative the time period, the time step, multiplied by P, the value of the option if the stock price goes up. So that's our CU. Just look at this for a moment. So P, this our P gets multiplied by 4918 CU plus 1 minus P times CD. And then we go down one step, and likewise the same type of cell referencing is occurring. We're taking the value, so E negative dt by R multiplied by P CU. Let's escape here for a second. M24. M24 is CU. 1 minus P by M25 is CD. And notice that once we cell reference these two, discounting back to the previous time period is just 0, and likewise 0 again. Okay, and then we go back again and we pull down again and we go back again, and so that's the sequence of the tree. So each time there's a double loop, and if you like, we're moving back through the tree incrementally. We're moving in a time step of -1, and again we have the same type of construction. It's the up. If you think of S11 as being a grid reference, we could think of the, if you like, up ij plus 1 as being this cell in terms of the cell, remember I denotes the row and J denotes the column. So it's one column in front, right? So the value of option here, this option, say 1, 4, is determined by 1, 5 and 2, 5. So option 1, 5 and option 2, 5. This cell here is determined by this. Okay, so, and that happens then sequentially using the combination of J and I. Okay, so the key point here is that the result that we obtain in this manual construction is the same as the one obtained in the tree, where we make explicit the number of steps is 4. Okay, so that's for a euro option. How do we change this? A euro call. How do we change this to obtain a put option for a European put? Okay, well, that's a relatively simple exercise. European put. Let's take our results again and copy. Home, copy, European put, paste. To change the value here from being for a call to being a put, we change the C to being P. Okay, so if we designate this as P, then the value of this option here is for the put. Okay, and then how do we change that here? Well, for a put option, if we're selecting for a put, PUT, then the change that we make, okay, is very simple. This set of steps in terms of the tree remain identical, but for a put option, we go from S minus K to K minus S. Okay, so we say, okay, it's not K S minus K, it's K minus S. So that's K. If we subtract away S, it's this value here. And of course, it goes to 0. Let's pull that down. And our tree completely changes. And the value that we have here, however, matches exactly the value that we have here. So for this 4-step tree, right, just simply changing the estimation here. So instead of using this case, right, which is what we started with, we are using this case. And let's make that, okay, so we're using this, which is what? It's K minus S. So if we look at that for a moment, we can see that's K minus S, and that's the same. So one innocent change produces this value here instead, which corresponds to the CRR tree. And in the next video, I'll look at how we can set out American options within the tree. What small change again is necessary to produce values here that are equivalent that are for American options, and illustrate how the Cox Ross Rubinstein tree is tremendously flexible in that regard.